Okay, I'll give you guys a second to copy this down. All right, let's work this example. If a pair of shoes costs $52.50, including a 7.25% tax, what is the original cost of the item before taxes are added? Okay, so remember the first step in solving one of these word problems is to assign variables. So let's call we'll use C for cost. So C is going to represent the cost of the shoes before taxes. That's what we're being asked to find. So we know that the amount of tax, we're given a rate. So to get the amount that we're going to pay in taxes, you take the cost of the item and you multiply it times the rate. So the cost of the item before taxes, multiply it by the rate, the tax rate, and that's the amount of tax that you're going to pay. The total cost is going to be the cost of the item plus the amount of tax that we're going to pay, which is the cost times the rate. So we're going to take the amount of taxes that we're going to pay, add it to the original cost of the item, and that's how we get the total cost. You guys know all of this. You just might not put it in math equations like this all the time, but you do it in your head when you're shopping for sure. At least with discounts and stuff. You may not necessarily do it with taxes as much, but you do this type of stuff all the time. Okay, so let's replace, in this equation, let's replace what we know. We know the total cost was $52.50. We don't know the original cost of the item, but we do know the tax rate. It's 7.25%. So let me do this, 7.25%. But when we plug percents into equations, we always have to change it to a decimal first. So 7.25% is 0.0725 because we move the decimal 2 places to the left. So C times rate, we know the tax rate, it's 0.0725, and we're still multiplying that times the original cost. So 0.0725 C. Now we can solve this equation for C. Okay, on the right side, we have C plus 0.0725 C. The coefficient on this C is just 1. So when we add them, we get 1.0725 C. To get C by itself, we need to divide both sides by 1.0725. Can do this in our calculator. 52.5 divided by 1.0725. We get 48.95. Rounded to 2 decimal places because we're talking about the cost of an item, and that's always 2 decimal places. So our answer then is the original cost of the shoes before taxes is $48.95. Any questions on this example? Okay, let's look at example 5. Okay, take a second, copy this one down. .125% annual interest rate. How long will it take $1,200 to yield $307.50 in simple interest? Okay, before we start on this problem, let's talk about the formula for simple interest. Hopefully you've seen it before. I equals PRT. That's a formula for simple interest. Here's what it stands for. So the amount of interest is equal to the principal, which is just the amount of money that you start with, times the rate, times time. So for this example, it's asking how long, which means time, the t is the variable that we're going to end up looking for. So in this formula, we have all the other parts. The interest is $307.50, so 307.5. The principal, or the amount that you start with, is the $1,200. We're given a rate of 5.125%. Remember, when you plug percents into problems, you need to change to decimals. So the rate here would be 0.05125 because we've moved the decimal 2 places to the left. We don't know the time, that's what we're looking for, so we'll call time t. Now we can solve this equation for t. So let's multiply here. We've got 1200 times 0.05125. That gives us 61.5 t. So to get t by itself, divide both sides by 61.5. 307.5 divided by 61.5 is 5. Okay, so what this answer means, we're asking about an annual interest. So our time is in years. So this answer means it will take 5 years we'll just say it will take 5 years to yield $307.50 in simple interest. Okay, we've got 2 more examples. So we're moving on to example 6. Okay, I know that this is a long one. I'll give you some time if you want to copy it. I also would not be mad if you wanted to just snap a picture of your screen and have the example to look at while we work it. That's fine too. Okay, let's read example 6 together. It says, after winning the state lottery, Mark has $40,000 to invest. He will put part of the money in an account paying 4% interest and the rest into stocks paying 6% interest. His accountant tells him that the total annual income from these investments should be $2,040. How much should he invest at each rate? Okay. I think the best way for us to get started here is to draw a simple chart. So we're going to look at the amount that he should invest, what rate that investment is going to have, and the interest that he's going to make from that investment. Okay, so the amount that he's going to invest, it says he will put part of the money in an account paying 4% interest. So it doesn't tell us a specific amount. It just says he'll put part of the $40,000 in this account. So if we don't know what value is, we assign a variable. We'll just use X. So he's taking some amount and he's putting it in an account that pays 4% interest. So the rate for this account is 4%. Let's go ahead and change that to a decimal. So the rate is 0.04. So the interest that he's going to get from this investment will be the rate times whatever the amount is that he decides to put in. So 0.04x. Okay, then it says he puts the rest into stocks paying 6% interest. So the rest of the money would be this 40,000 minus whatever he just invested in that account that pays 4%. So the amount that he's going to invest in stocks is 40,000 minus X. We could have assigned another variable. We could have said, okay, well, this investment is Y. X and Y, we don't know what either of them are. So we'll just assign them different variables. And that's fine until it comes down to actually solving this problem. If we have two different variables, two different unknowns, it's very difficult to actually solve. So if we can write our unknowns in terms of the same variable, that's going to help us. Okay, so we've got some amount invested at 4%. The rest, which is the amount we started with minus the amount we just invested in the other account. This is invested in stocks that pay 6% interest. So our rate is 0.06. So then the interest made from this investment is the rate, 0.06 times the amount that he invested, which is the 40,000 minus X. So if we look at his total investment, which is $40,000, the amount that he's investing in total is $40,000. It's going in at different interest rates. We're just going to skip over this section. But his total interest, we're told, or his accountant told him, should be $2,040. The interest that he should get from all of his investments should be $2,040. So if this is his total amount of interest that he's going to make, then that means whatever these two, this amount of interest, 0.04x, and this amount of interest should add up to equal 2040. So let's make a note of that. So these two should add to equal the total. However, you need to write that so that you can remember that that's what we actually did. So adding these two lines of interest should equal the total amount of interest that his accountant said he should get. So that equation is what's going to allow us to solve this. So we're going to add these two and make it equal 2040. So we've got 0.04x plus 0.06 times 40,000 minus x equals 2040. Now we can solve this equation for x. So let's get rid of these parentheses by distributing 0.06. So we have 0.04x plus, we use our calculator, 0.06 times 40,000 is 2,400 minus 0.06x equals 2040. Combine like terms. So we've got 0.04x minus 0.06x. That gives us negative 0.02x. Subtract 2,400 from both sides. $2,040 minus 2,400 is negative 360. And to get x by itself, divide both sides by negative 0.02. We get 18,000. So x equals 18,000. Let's go back to our table to see what x represents. X represents the amount that Mark should invest in the account that pays 4% interest. The question that we're asked is how much should he invest at each rate? So we know the amount that he should invest at 4%. We still don't know what amount he should invest at 6%, but we know that that amount is 40,000 minus X. And now that we know X, we can find that value. 40,000 minus 18,000. $22,000. So now we have our solution. Mark should invest $18,000 at 4% and $22,000 at 6%. Okay, we've got one more example to look at. This will be example 7, and then we'll be done. Okay, take a second, copy this example down. Okay, example 7. A chemist must mix 8 liters of a 40% acid solution with some 70% solution to get a 50% solution. How much of the 70% solution should be used? Okay, we're going to draw another table to help us keep all of our information straight. So we've got number of liters, the percent solution, and then the liters of pure acid. Number of liters, percent solution, and the liters of pure acid. So the first thing it tells us is that this chemist has 8 liters of a 40% solution. So 8 liters of a 40%, let's go ahead and change that percentage to a decimal. That's 0.4. So within that solution, to find the liters that is just pure acid, we take the total number of liters and multiply it by the percent of acid. So this 8 liters is 40% acid, pure acid. If you multiply 8 times 0.4 in your calculator, you get 3.2. So in this 8 liters, there's 3.2 liters of pure acid. That's what makes it a 40% solution. The next thing it tells us is that they're going to mix that solution with some 70% solution. It doesn't tell us how much, so we'll use a variable. X number of liters, we don't know how many. We know the solution is 70%, which as a decimal is 0.7. So the liters of pure acid will be 0.7x. Okay, so again, in this third line, we're going to think about totals. So the total number of liters after he mixes this will be the 8 liters that he starts with plus however many liters he uses of the other solution. So 8 plus X is his total. The percent solution that this new mix is going to be is 50%. It tells us that's what they're trying to do, is make a 50% solution. So the percent solution will be 0.5 for the total. So the liters of pure acid will be the percent solution, so 0.5 times the number of liters, which is 8 plus X. So just like in example 6, these two lines, when we add them together, they should equal this total. So these two lines added together should equal the total. And that's how we'll write our equation. So we've got 3.2 plus 0.7x. When we add those together, we should get 0.5 times 8 plus x. So now we have an equation that we can solve for x. Let's get rid of the parentheses on this side by distributing 0.5. So 0.5 times 8 is 4. And 0.5 times x is just 0.5x. Okay, we have an x on both sides of the equal sign. We want all of the x's on the same side. So I'm going to move 0.5x to the other side by subtracting 0.5x from both sides. .7x minus 0.5x is 0.2x. So we get 3.2 plus 0.2x equals 4. Now that we have all the x's on the same side, we want that to be the only thing on this side. So subtract 3.2 from both sides to get rid of that. So we get 0.2x equals 0.8. 4 minus 3.2 is 0.8. To get x by itself, we divide both sides by 0.2. 0.8 divided by 0.2 is 4. So we get x equals 4. So in this example, x represents the number of liters of the 70% solution that this chemist should use. So our answer is the chemist should use 4 liters of the 70% acid solution. Does anybody have questions over these examples?